All right, so I'll start recording now. But so sorry, I forgot to start recording. But these two boxes here are the formulas we're going to be using today. Okay, and basically what a z-score tells you, if you're like actually trying to understand what we're doing, is a z-score basically tells you where you fall in your curve. So if you had a z-score of 2.5, that means you're here. Basically, one thing a z-score is useful, you can figure out what percent of people you did better than if you know your z-score. We probably won't be doing that in here because you really want to use like a graphing calculator to find, it's called a percentile. We don't, well, and there's tables and stuff, but we probably won't do it this year just because of kind of what it's looking like. All right, so we're going to look at some examples, but you're going to want to reference these formulas. So I would really either take a picture or write these down, have them handy. But we're going to look at some problems, and I might skip some of these problems because there's quite a bit of examples. We got front and back of this, but they say listed below are the grades from Mrs. Grubin's Algebra 2 class. Honestly, we don't really care about the actual scores because they tell us what the mean is and they tell us what the standard deviation is. If they didn't tell us that, we'd have to figure those out, and we've seen how to do that by hand, but it can be quite a pain, especially if you got a lot of numbers. So it says Addison scored an 86 on the test, find his z-score. So we're going to use the formula, like this formula here. So if you were doing that, you would take his score. That's going to go in place of the x. So you would do 86 minus the mean, which they told us here was 80, divided by the standard deviation. The only thing you got to be careful when you put this in your calculator, put the top in, press equals, then divide by 6. Don't try and put it in all at once. That's where you're going to mess up with these. But if you did 86 minus 80, you would get 6. Divided by 6 is 1. Keep in mind, like your z-score, if you think about your curve, you should get a z-score that's usually between -3 and 3. If you get a z-score that's like 10, 20, 40, you messed up. You put it in your calculator wrong. So keep in mind, your z-score, like the answers you should be getting when you're finding a z-score, should usually be between -3 and 3. If you get like a z-score of 10, you probably did it wrong. So just double check your math or how you put it in. So same idea with this next one. It says Charlie scored a 72. We're still going to use that same formula because we want to find his z-score. So we're still using this one that I have highlighted in pink. So his z-score would be 72 minus the mean, which is 80, divided by the standard deviation, which is 6. So like I said, just be careful when you put this in, put the top in, press equals, then divide by 6. So you would have -8 on top, divided by 6. If you plug that in, you'll get -1.33. Keep in mind, a lot of times with these z-scores, you will get a decimal. All right, this next question, they tell us what Jane's z-score is. We want to know what she actually scored on the test. So this is where we're going to be using, I'll highlight it in green, I guess. We're looking at this raw score formula. So you would take the z-score, I'll just write what we're doing, z-score times the standard deviation plus the mean. Like that's the formula we're going to use. So that would be 1.5 times 6 plus the mean is 80. And this you can put like all in your calculator, no worries. What did you get, Armand? Did you get the answer? I thought it said. Oh, okay. I thought you said the answer. If you plug it in, I got 89. Just plug that in. Okay, I'm actually going to skip this question. I really don't like. I think this question doesn't really make a ton of sense in terms of this context. So I'm actually going to skip example 2 if you want to as well. But for this next one, we'll look at this one. It's pretty much its own question. It says Liz's standardized score on the math portion of the SAT was 1.9. That's the z-score. They tell us the mean and the standard deviation. They want us to find her actual score. So we're still using this formula we just used in the last problem. So you would take her z-score times the standard deviation, which they tell us is 100, plus the mean, which they tell us is 500. So if you plug this in, like if you don't have a calculator handy, you should get 690 though. All right, so on the back side of these examples, oh, he's not supposed to be in this period. Similar idea, we're still using the same formulas from the other side of this, so I might have to scroll up to show us, but they tell us the standard deviation is 10. And so we're going to figure out some z-scores. So this first one, they tell us the raw score is 80, like you actually scored 80, and the mean is 30. So if you're trying to find your z-score, remember it's your score minus the mean over the standard deviation, which they tell us up here. So if you just work this out, that would be 50 over 10 or 5. This question too, I mean, I'll do it. I think it's a little bit confusing how it's worded, but it says a score that is 30 points below the mean, what would like the z-score be? Because that's what they're asking us to do here. Sorry, they asked all these questions, we're finding the z-score for 1 through 3.
0.
If you think about a normal curve, I don't know if this makes sense. If you're at your mean, you're like at 0, right? So if you're 30 points, if each standard deviation is 10, like you would be 2 standard deviations to the left, because it says like you'd be at -3. Because if you're going down by 10, you'd have -10, -20, -30. So the z-score for this one would really be -3. If this doesn't make sense, don't stress too much. There's not really one like this on your assignment. Number 3, it says a score of 50. So your score was 50. Oops. Minus the mean, they tell you is 40. All over your standard deviation, which is 10. Like the standard deviation is 10 for like all these questions in this section. And like I said, I'm going to skip questions 4 through 6. I think this is a typo. This is supposed to be 160. Yeah, what's going on, Tyler? Here, let me just pause it so I'm not like examples though. All right, so finishing up 7, 8, and 9. So this is kind of its own thing. It says students take a test that measure the same skills. Which is the relative highest score? Compare the z-score. So at the end, they want us to compare these, but it says Sue scored a 21, so that's like an X. Like that's her actual score. They tell us the mean. They tell us the standard deviation. So that's the z-score formula. And like I said, I know it might be kind of annoying, but we're using this pink box formula. So X minus mean over standard deviation. So 21 minus your mean of 25 over 5. If you work that out, that would be -4 on top. Divided by 5 would be -0.8. And like I said, a lot of times when you're doing these z-scores, you're going to get decimals. On this one, it says Sam scored a 90 with an average of 85. So that's going to be the top of your fraction. And then divided by the standard deviation for him is 12. So that would be -5 over 12 once you, or not -5 actually, sorry, +5. Because 90 minus 85. And if you divide that, what's that? 5 divided by 12. It's approximately 0. Oop, didn't mean to erase that. Is approximately 0.416. You could round that if you'd like, but that's their z-score. And then the last one, Jeff scored a 144. We're going to subtract the average. They tell us is 128 divided by 35. If we simplify that, 144 minus 128, press equals. That's 16 over 35. So that is roughly 0.457. And you could round, I mean, if you want to put 1 or 2 places, but I would probably put at least 2 places because we're comparing these answers. So in the directions they asked which had the highest score relative to each other. So I mean, if you just look at our answers, it would be Jeff because he had the highest z-score.